Question number 61. I can get to it. Hang on one second. Question number 61 is also asking us to find the value of x. And looking at all these angles, angle ABC, BCD, CDA, DAB, every one of these angles is an inscribed angle. So in this case, we are looking at inscribed angles. None of these angles, and again, hope you guys can see the difference between 61, where all the angles are inscribed, compared to question number 58, where all of the angles have the center of the circle as the vertex. These are all central angles. And question number 61 is inscribed angles. Now, we learned a property of an inscribed quadrilateral, or a polygon with 4 sides, inscribed or drawn inside of a circle. And we learned that the opposite angles of a quadrilateral or 4-sided polygon that is inscribed in a circle must always add up to 180 degrees. So the nice part is they've told us what the measure of inscribed angle ADC is. That's 110. So to find the measure of x, or the value of x, all we have to do is take 180 degrees and subtract 110 degrees, and we're going to end up with a value of 70 for x. So x is going to equal 70 degrees, or x equals 70. Alright, quickly, just to explain this to you, why this is the way it is, if you can picture this angle right here, ADC, that's an inscribed angle, and it intercepts arc ABC. And then if you also look at this angle, inscribed angle ABC, that intercepts arc ADC. Now take a look at these two inscribed angles. ADC intercepts arc ABC, and angle ABC intercepts arc ADC. Well, look, those two inscribed angles intercept the entire circle. And we know that an entire circle equals 360 degrees. That means we know that these two angles have to add up to half of that measure, since we know the inscribed angle is half of the measure of the intercepted arc. So if the whole circle is 360, these two inscribed angles must add up to 180 degrees, and that would make sense that 180 times 2 is 360. That would be the entire circle. And if you follow that property, that helps you understand why these two opposite angles have to add up to 180 degrees. If it's a little bit difficult for you to picture the relationship between those two, then you can just fall back on the rule that we learned, and that is that if you draw a quadrilateral inside of a circle, we know the opposite angles of that quadrilateral always have to add up to 180 degrees, and that makes this problem actually fairly quick to solve.